All right, guys, continuing on with the chapter, kind of in a hurry to stop talking about functions so that we can move on to the next thing. But this is important enough to continue to focus on it. So scope. Scope is the area in which a name refers to a given value. Temporary variables, or we should say local variables, that's my name for them, that's what other textbooks call them, but they're calling them temporary variables, are restricted to the body of the functions in which they are introduced. So we have a function, whatever it's called, any variables defined in it, right? Define my function, whatever, a equals 1, right? They're calling that a temporary variable. I'm going to call that a local variable, and I'm going to note that the book calls it temporary. Temporary variables have a scope that ends where the function ends. So somewhere down here, maybe we do something with A, I don't know what, we add 1 to it. We print it out, whatever, right? And then we return. So by the time we've returned, that variable no longer exists. Unless we return that variable. We could do that, right? We could return that variable. And then when we call the variable, if we do x is equal to my f like that, it's going to get the returned value. So really, the value didn't exist anymore. The variable doesn't exist anymore, but the value that it calculated does, and is now stored in a different variable. So a variable declared outside of all functions is a global variable. Now, since we have not taken much time to be putting things inside a main function, pretty much every variable we have created is a global variable. And that's kind of bad programming. I should have been making y'all do everything inside main function. Maybe I'll do that as an example to the rest of the class. So parameters are invisible outside the function definition. In other words, a parameter is another form of local variable. If I make a variable that looks like this, right, I'm going to create another one, right? Define my2, right? And it's going to take a variable called name, right? That's the parameter variable. Name is the parameter, which you can also call a parameter variable. Parameter is a variable that is local to the function. So I can't get a hold of name down here, right? I can't print, name right here. Just because it was declared here, it stops being declared when the function ends, right? So if I do print hello, end quote, comma name, right? Sure, it does something. So I can pass it in as an argument, right? My2, and I can pass in a name, right? So Bob is the argument that fills the name parameter variable, the my2 function. I'm going to put this stuff inside a main method just because that is good programming. Now, I guess I already said that this was out of it already, but the rest of it I'm going to do, right? So let's define a main, right? Let's put these things in here inside main. Let's put the main function above this stuff right here. This line does not work, so I'm going to delete it. And then here I'm going to call main, right? And really these two lines should be part of main as well. I should tab them over or whatever, but other than the comment, global variable is inaccurate. So a global variable is one that's accessible inside all of these variables. In all of these functions. If I make a global variable called gravity, 9.8. So, right, gravity is 9.8 meters per second squared, right? Then I could print gravity inside any of these functions. Inside main, inside my2, inside any of them. I'll just prove it by printing gravity right here. Print gravity, comma gravity. Let's run it. Which lecture are we on? We're on R? Yeah, I believe so. No, I think we're on lecture S. All right. And I accidentally called it lecture D. D is right next to S. Oh, well, in my comments, I guess I'll call it lecture S. Okay. Why isn't it letting me type anymore? Well, okay. There, now it is. That was odd. So this is chapter 5 continued. Now I'm going to run it. Now I like to see my global variables defined up at the top, but it's not strictly necessary, right? Any variable declared outside of all the functions is a global variable, and it's going to be available to any of the things defined within it. Let's prove that to ourselves. I did not mean to launch the shell. I meant to run the program. Right, and so the gravity was 9.8. Don't use global variables unless you have to, unless there's a good reason for it. If you have a variable that needs to be declared among, that needs to be shared among multiple functions, it's okay to do that. Now, if we wanted to change that variable, and I talked about this a lot the last lecture, we're going to change gravity to 10. That's not going to work. I mean, it may not give me an error message, but it's not gonna work, especially if we did something like this. Gravity plus equals 1. That's gonna be bad news. Run the module, and it blows up because it's acting like it's trying to treat it as a local variable. And that's kind of a little odd quirk about Python as far as I'm concerned. So if I want to be able to change it, I can. I just have to use the global keyword. Now the function can change it, right? So although a Python function can reference they're calling it a module variable. I've been calling it a global variable. They're calling it a module variable. I guess I better take note of that. Why don't I move gravity up to the top? The book calls them module variables. They're allowed to pick their own nomenclature if they want. Since I've defined gravity up here at the top, I'm going to remove it from down here. Guess I'll leave that comment. Whatever. Okay. Back over here. If you try to assign a new value to a global variable, it creates a new temporary variable. And if you're using PyCharm, you get a message about shadowing the variable name. And so that's why you need the global keyword. So the variable's lifetime is a period of time when the memory storage is available to it, when the variable exists. And its lifetime is from the point where it is defined to the end of the function. if it is a local variable, or until you close Python if it is a module variable, if it's a global variable. Using keywords for optional and default arguments. I talked about this some. We can give ourselves some default values. I'm not going to talk about this much because, like I said, we have done so. Like, say I'm going to print out happy birthday, define B-Day, and it's going to take somebody's name, but it's also going to take an optional number of times it's supposed to repeat, right? We're going to get it at a default name, right? Our default name is person, right? That's pretty generic. And the default number of times to repeat is 1, right? I'm only going to do it 1 time by default. And so let's have a loop. For I in range, the number of repeats, for I in range repeat, print happy birthday, comma, name, right? There we go. Then return. All right, so, whoops, I accidentally moved my colon there. I'm going to call B-Day once with no values. I'm going to call B-Day a second time and pass in the name of a person. And it's only going to do it 1 time because I did not specify it. I'm going to call it with both values, right? Jim, I want Jim to get 3 birthday messages. I'm going to call it, and I don't care who, but I'm going to say that repeat is equal to 10. So it's just going to print happy birthday 10 times. Well, that's a bit excessive. How about 5 times? And I can say B-Day name equals Sam, right? Comma, repeat equals, 2. Lastly, I could reverse those orders because the variables have their names. Repeat equals 3, comma, name equals Judy. Like that. So now we're going to litter up our screen with a whole bunch of birthday messages, but hopefully that makes sense. Once you start providing default values, you get the ability to do these kind of things, to leave out arguments, to provide some of the arguments but not others, or to give named arguments to fill in the parameters, right? Run it. Make sure it works. Make sure I didn't lie. All right. And there it's doing all the stuff that we told it to do. Bob only got 1 name. Let's go see why that is. Oh, that's a hello message, not a happy birthday. All right. So those are default optional arguments. Higher order functions expect a function and a set of data values as arguments. The argument function is applied to each data value. Now this is getting pretty twisted. A higher order function separates the task of transforming each data value from logic of accumulating the results. So ABS is a built-in function. Import math, we can find out that math.sqrt is a built-in function. And then we can say F is equal to ABS, and then we can call F. And it's twisted, but we can do it. Let's go back to our code. And here I'm going to say, we have the print function. We can call this function show is equal to print, and then we can show some data. Isn't that weird? You can do that. You can write a function that calls another function like that, right? So I'm going to write a function called higher because it's a higher order function. It's going to take a function name, which I'm just going to call func, comma, and then maybe a list of values. right? And so then it's going to have a for loop for every value in the list, call func with that value, right? So then up here, if I do higher, well, let's make our list first, right? List is equal to, 1 comma, 5 comma, yeah, let's make it real obvious, 1, 2, 4, 8. Right? And then we call higher, and we're going to pass in the print function, and we want that to be the data. And so it's going to print them 1 per line, right? Because it is going to use this to fill in that, and then it's going to call that function on every value in the list. Higher order function. A higher order function accepts, takes a function as an argument. I think I'll make sure it runs before I add any further comments. Right, and it printed out our array, 1, 2, 4, and 8. Excuse me, I called it an array, it's a list. All right, so it's just going to print wow, comma, value. And I'm going to put this in a comment down here, right? So an example of how this function would be called is this, right? I'm not going to spend a lot of time on that because honestly, in this language, I haven't used that concept much. But you can use it. It's kind of neat to be able to pass around functions. And if we can't come up with a good quickie explanation of why you would want to do that, but you can. It makes your code more flexible. So mapping applies a function to each value in a sequence to return a new sequence of the results. So we're going to take a series of words and we're going to call map. Oh, good grief. When I said series, Siri thought I was talking. All right. And it's going to apply that function to every item in that list. Let's come up with some example for that. I'm going to write a function called double print that takes X and prints doubling X, right? All it's going to do, print double X equals, end quote, X times 2. That's all it's going to do. All right. So now that we have this list here, let's map, whoopsie, that data set L using double print. In other words, call double print on every item in the L list. And we've already seen this happen with list comprehension. I guess I didn't see the map function work. I guess I never saw it say double. Did it ever call it at all? I don't think so. I did it wrong. Honestly, I don't use the mapping. I haven't learned it adequately, but I should have. All right, so for example, int returns a value. This function probably should have returned a value, because if we're going to double it, then we would want to return X times 2. And then down here, we could say that list2 is equal to the map version of this. So we're going to call double print on every item in our list and store the results in L2. And let's print out L2. L2 equals, end quote, comma, L2. All right, L2 is a map object at that. Let's go look and see what we wanted to see here. We need to convert it to a list. What do you know? This is turning too complicated. I'd rather just write list comprehension. I'll show you how I would have done list comprehension. Anyway, so we got to do list of the map of that. That syntax is nasty. I'm not digging it. Alrighty, let's go. And there we see it work, right? It doubled each one of our values. 1248 became 24816. Oh boy. Could have done the same thing with list comprehension. Let's make a comment as to what this does. Map will call a function for every element of a list. You can do the same thing with list comprehension. Say I want to double those numbers again. L3 is equal to double print. No, that's not how you do it. L3 is equal to, you use the square braces to start your list comprehension, and you call double print X for X in L2, right? Take every item in L2, call that function, and store the results in L3. So print L3 is equal to, end quote, comma, L3. Let's put some comments here. After mapping, L2 is that, right? And after list comprehension, L3 is that. Or if we passed in L1, then we should get the same results each time, right? If we just pass in the original L, rather than doubling it again, if we're going to use the same thing as input, we should get the same results as output. Let's make sure that's the case. Right. Did the exact same thing. 246, 24816, 24816. I like that syntax because that's how I grew up, right? It's just the first one that I learned. And since I learned it, I never really learned mapping. There's nothing wrong with doing that. You can certainly do it that way as well. This one just happens to make more sense to me. There's probably a quiz question over mapping in Mind tab, so just try to memorize it. Calls a function for every element in a list. Their example is this. L4 is equal to the list version of the map version of, and I want to convert everything in this series to a float. So please turn it into a float, and here's the values that I want to convert. I want to convert 1.1, end quote, comma, and then the syntax is kind of nasty, 1 quote, 1.2, end quote, quote, 1.3, end quote, right? Maybe if I space it out a little bit more, it'll look a little bit better. Probably not. Maybe I should have stored this in a variable and then passed it to it, right? So I could call this num list, right? Is equal to that. And then I could pass the num list in. Need my second parentheses, which I seem to have forgotten, right? And then I'm going to print out the num list and L4. And we will see that this list of strings has been converted into a list of floats. right? We see it there. As soon as it stops scrolling, this list of strings got converted into a list of floats. Could have done the same thing with list comprehension. L4 equals square braces, float parentheses x for x in num list, right? Either way works. So I want to kind of veer off just a little bit. I'm going to talk a little bit more about Caesar Cipher. Haven't we talked enough about that? Yeah, we have. But it also happens to provide good examples for this kind of function, right? So what does Caesar Cipher do? It adds a number, takes a value and adds a number to it. So we're going to write a function that takes a number and adds a value to it, right? And then if that number is, let's not even bother shifting it. Let's just write the simplest version possible. So we're going to write something called shift that takes an element and a shift, and it returns, or result equals x plus shift, return the result, right? Now I'm going to write a function that takes a string and turns it into a list of ASCII values, right? So that if I give it the string ABC, I want that to become a list that looks like this. An A is a 65, a B is a 66, and a C is a 67. That's what I want this to do. So I'm going to call this one string to ASCII list. It's a lot to say there, but I don't think it's too hard. And it's going to take S as its string. So what is it going to do? We could use list comprehension. L, or we could do mapping. List comprehension. L is equal to, and what function are we going to call? The ORD function is the function that creates the ASCII value from a character. So ORD C for every C in S, and then return L, right? So string to ASCII list. For every character in the string, turn it into an ordinal, and then return that list. L equals square brace, ORD parentheses C in parentheses for C and S, return L. Now how about a function that goes through that list, shifting all the values? Sounds like a job for more list comprehension. Define shift list values. And it takes a list. I like calling my lists L, so I'm just going to go with that. All right, so list equals, let's use list comprehension again. How to mix it up, right? I'm going to stick with list comprehension because I've shown you that in the past. So for every value in the string, shift X for X in L. Now you may wonder why I use C there and X there. Well, I was thinking C is going to be a character in a string, and so it kind of made sense to me, and X is a number, and it doesn't matter. Variable names don't matter. I could call this for every Fred in L, do it, right? Convert every character in the string into an ASCII value in a list. That's what that function does. What does this function do? Shift every value in the list. When I call shift, I need to not only pass it the data, I need to pass it the shift value. And now I'm winding up with things that have multiple names, right? I'm going to have shift as a function, and then shift as a variable. I'm not liking that. So how about I change this name a little bit to shift value, right? That's not too bad. So when I shift the list values, it needs to take the list and it needs to take a variable indicating how far to shift. And we need to pass that variable in to this function. So rewriting our list comprehension a little bit, shift underscore value. X, comma, shift for every X in L, for X in L. And then return that list. And then how about one more function that takes a list and turns it back into a string, right? I'm going to move this as a comment here. I wrote that comment and I'm putting it there, right? This one's going to do the opposite. So def ASCII list to string. It's going to take a list and return a string. So 65, 66, 67 is going to become, quote, ABC, right? That's all it does. Well, we're not going to use list comprehension. We're going to use join. We want to join every value in that list. No, I don't think we're going to use join because we'd have to convert it to a list of characters first before we could call join. So I'm just going to do it like this. I'm going to declare an empty string. And then for every value in the list, for V in L, S plus equals the character value of V, right? So for every number in the list, do I not want to use V? I could call it X, right? For every value in the list, convert it to a character and add it to S and then return it. All right, with these three functions, four of them actually, right? Because we have this shift value function. We have this string to ASCII list function. We have ASCII list to string function, and then we have shift list values. Now our main program that does an ASCII, that does a Caesar cipher, it's just going to be a few lines long. The only thing that we would really need to fix to make this a better Caesar cipher would be that line right there. Right? Because if it goes past the edge of the ASCII list, if it exceeds 126, then it needs to start back down at the beginning, the 32. Okay, let's do that. So let's get our data. We should ask them for it, right? Text equals ABC, right? That's enough. Okay, fine. ABC shifted. How about that? We need to convert that to a list. So we're going to call string to ASCII list. So list is equal to string to ASCII list, parentheses text. Now we need to shift all the values in that list. So L2 is equal to shift list values of that list by the shift amount. I never defined the shift amount. Let's shift everything by 1, right? It's real easy to see. Then we need to turn that back into a string so we can print it out, right? So So ciphertext is equal to ASCII list to string from that list we just made. And let's print it out. Print shifted text is, in quote, comma, ciphertext. And let's print out the original string too, right? Just because we didn't actually ask them for it, but we should have. So print original text is, in quote, comma, text. And then let's just put an input statement here so that it doesn't keep going and do all the rest of it, right? All righty, so the original text was ABC and then it became BCD, so it worked. What if we want to encrypt it? We would just pass in a negative shift value, right? You can do the same thing again, you know. Anyways, isn't that pretty neat? Those 3 lines of code do our Caesar cipher. If you used a negative shift value on the results, then you could, you know, recreate your original text. And by the way, since one of your projects involves Caesar's cipher, you can take advantage of this code, right? We just use some judicious list comprehension. But remember, list comprehension is just a replacement for something like this. I'm going to type it and then I'm going to delete it. Or maybe I'll just add it as a comment somewhere. But this statement right here, I'll add it as a comment to the bottom, is the same thing as, why don't I put it inside some green text? Creating an empty list, right? And then writing a for loop. For C in S, colon, for every character in the string, L dot append the ordinal value of C. Just does it in one statement where this takes 3. I'd rather write it like that rather than write 3 lines of text, right? It's up to you. Of course, all the examples I just typed up there did that. All righty, I actually think this is about enough. Let's go look at the PowerPoint and make sure if I agree with that statement. We've talked about mapping. Filtering. When filtering, a function called a predicate is applied to each value in the list. And if the predicate returns true, the value is added to a new list. Otherwise, the value is dropped from consideration. So it's like a map, except it uses a function here to decide whether to include it or not. That's what we're talking about just for a little bit. So let's create a filter that returns true if the number is evenly divisible by 5. So DEF even 5, right? 5, 10, 15, 20, 25, 30. How are we going to check that? We're going to modulus our number, right? R is equal to X modulus 5. And if R equals 0, that means it's evenly divisible by 5. So return true. Otherwise, return false. All right, now we can use that, right? Let's make a list of numbers. Some of them are going to be, oh, stop that. Some of them are going to be multiples of 5, some of them are not, right? Let's make our list. L2 is equal to the list version of the filter even underscore 5, comma, that list, closing enough parentheses to get it to actually work, 1, 2, 1, 0. And then let's print out the list in list 2. And list 2 is only going to be 5s. Then let's add an input pause, right? Right, and so our original list was 1, 2, 5, 10, 11, 15, 18, 20. After it got filtered, that was the result. I can honestly say I've never done that in real production code when I was, making a living programming. It's interesting. So let's make some more notes way down here at the bottom. Map is like list comprehension. It calls a function on every element of a list. So for example, L is equal to map function, right? L. We had to include it in a list function like that. Call func for every element in L, returning the results to replace the list, right? Or let's just make it L2, right? That was supposed to be L2. And then filter. Filter allows creation of a list based on a condition. Only elements, I typed a 0 there, then wrote a no. Only elements that match the condition are added to the list. So L2 equals list filter F comma L, where F is a function that returns true or false. I better capitalize true, based on whatever condition. So that's what a map does, calls every function for every element in a list, returning the results to be stored in another list. Change that to an equal sign. Whereas a filter does kind of the same thing, but it calls every function, it calls a function on every element in a list to conditionally decide whether that should be part of the new list or not. And we have examples of both of those up higher in the code. And I better put a comment that this is list comprehension. All right, it's about enough, 45 minutes, more than enough to talk about. I'm going to skip reducing. I guess maybe we'll talk about, I wanted to talk about classes today, but I'm glad that we went ahead and knocked out the rest of this chapter. You can read the rest of this chapter, but it goes in a little bit more detail than I think what you probably need to know if you sit down and you're wanting to write a scripting for security purposes or system administration or whatever. This is talking, maybe I'll make an optional lecture about it. but I'm really kind of eager to get on to talking about classes. So gonna stop there.